All right, testing 1, 2, 3. Testing 1, 2, 3. I see green lights there. That, of course, means we are live. Greetings, travelers. How are y'all doing? Hey, good to see you. Welcome, welcome. Alright, let's hide this. That's Stellarium, that's okay. So, it's been a while since we've done a Friday, quote-unquote, 3 o'clock coffee. Normally what we do on Fridays is basically whatever y'all want to do, because I could do a planetarium show, or I could sit around and talk about the news, or we can kind of click around and just talk about whatever. It's kind of the way we've always done our 3 o'clock coffees, our Friday shows. But as always, we're going to start off with the astronomy picture of the day. Now, if you are new to the channel, please be sure to like and subscribe. We are on 3 different websites at the moment. We are on Facebook right now, live. We are on twitch.tv right now, live. And we are on YouTube, also live. We are triple streaming all at the same time. Hey, I'm in a class and a test proctor. Oh, you're proctoring an exam. Look at that. Quality. That's some quality test proctoring right there. But yeah, today is more about just kind of talking about whatever. So I got a couple of things up here that we're going to talk about. We can use the various softwares to kind of look at them up close if we can. Or again, just kind of talk about whatever. I'm not going to do a full planetarium show unless y'all want it. It's just, it's Friday. It's Dress Down Friday. Just kind of hang out. But we always start out with a astronomy picture of the day. And let's start out with that. And if I probably forgot to say this, my name is Mike. If you are new to the channel, it's good to see you here. Mike speaking into a mic. Look at that. This is today's astronomy picture of the day. This is Messier 106. This is a galaxy, much like our own, a big spiral galaxy. Now, oops, that is the wrong software. That is also the wrong thing to click on. Good start. Good start to the show. This is Stellarium. You can find it at stellarium.org. I am not affiliated with them. I just like using it because it is an open source free planetarium software. There we go. So the object we're about to talk about is actually visible in the night sky tonight. Where the blinking cursor is, to find it, you're looking for the Big Dipper, Ursa Major's stomach and tail. Ursa Major is this big bear shape up here. And the Big Dipper is 3 stars making a tail, 4 stars making the cup. The pointer stars, these outer 2 stars out here, they point you towards the North Star, that is Polaris. Right there. Now, the object we're about to look at, again, you can see tonight if you have a telescope. As you can see, we're going to zoom in and see what it looks like here. So, there's a companion galaxy up here. It's the top left of the image. And this is a kind of a blurry picture of M106. Now, M refers to the Messier catalog. Charles Messier, who was a comet hunter, actually kept track of things that were not comets. As such, he made a list of objects that were there so that people could find them, but they weren't the things he was looking for. So this little spot right there, you zoom in with something spectacular, with something like the Hubble, you get something more like this. Now, the image obviously has been flipped because this galaxy is now, instead of on the top left, is now on the bottom right. But this is Messier 106. It's a beautiful, beautiful galaxy, and you can actually see a lot of things going on in this picture. First, let's zoom out a little bit. All right, so we've got this. They call it an island universe. No, this is a galaxy. This is a collection of stars and gas and dust. And with these stars, likely many, 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 many planets. Imagine if every star had 8 planets like our sun. Well, if you've got, let's say, 200 million stars, that's 200 million times 8. You do the math. It's a lot of planets. Now, not every star has planets around it, unfortunately, but that's just kind of an estimate to get your mind wandering. Let's zoom in and look at this section by section, shall we? Stars in our own Milky Way, when we take pictures of distant galaxies, stars in our own galaxy tend to have these little cross-stitching, cross-hatches, these rays shooting out of them. You see one there, you see one there. Couple others, but not too many. The rest of this is all this particular galaxy, and that's actually where we're zooming in, right into the middle. So, this is a spiral galaxy. What does that mean? It is a galaxy that has a spiral shape. Now, there's a couple of different kinds of galaxies. There are elliptical galaxies. I imagine a big conglomeration of gas and dust and stars, but in the shape of kind of like a football. Then you've got spiral galaxies like this one. There's variations on them. Some of them are very, very wide. Some of them are very compact. Some of them even have what's called a bar down the middle of them. That's called a barred spiral. So there's little subsets of them. And then there's a third type of galaxy called an irregular galaxy. And those are galaxies that don't look like footballs. They don't look like spirals. They either are malformed, they haven't truly formed yet into what they're supposed to be, or they were a spiral or an elliptical galaxy that maybe collided. Collided's the word we're going to use, but, you know, because galaxies are spread apart fairly well and stars are so far apart, you know, they don't really necessarily collide like you running into me in a hallway. When galaxies collide, you know, the gravity of the galaxies tend to shred the other one apart, and so you can get these weird these weird irregular shaped galaxies. Let's take a look at this one. When we zoom in a little bit, you see the actual core of this galaxy. Now, in the middle of at least spirals, not others, you have what's called the active galactic core. Usually it's going to be at least one supermassive black hole, an area of space so dense that not even gravity can escape it. We can't necessarily see it, but we see things around it, and the motion of stars and gas and dust around those black holes is incredibly fast. That's how we know there's a lot of gravity nearby pulling on them. Now, this particular photo has a very red tinge to very specific areas in this galaxy. Now, these reddish areas are clouds of gas and dust that are forming new stars. They call them stellar nurseries. Stars aren't born like a human. They are, you know, materials that coalesce into a large nuclear furnace in space. And all of these little red areas you see here and here and here, there's even some that are kind of floating away from the galaxy up here. These are all areas where stars are being born. There's also some kind of stray gases here and here. Sometimes when galaxies, you know, they're spinning around, the entire thing is, they shred apart some of these stellar nurseries. Also depends on what's been nearby. Sometimes gases are pulled away from the main body of a galaxy. You see a huge amount of dust kind of... Can we zoom in a little more? That's as far as we can go? Okay. It's gonna get a little blurry. I apologize. That's the best we can do here. You see that there's actually you can see the motion of this dust. So this was all kind of in a lane, one of these spiral arms, and now as it's approaching this, again, the black hole somewhere in here, surrounded by clouds of very, very heated gases and stars and things of that nature, you see this motion. This is dust, and the gas is being pulled in towards the black hole itself. Very, very interesting photo indeed. Very interesting galaxy. Now, it's not the only galaxy in this picture. If you've been paying attention, there's the companion galaxy way back here. There's also another galaxy kind of hanging out to the bottom left of this image. But those aren't the only ones. As I always show, when you look at these photos, you really want to look in the backgrounds, because there's always other galaxies. Spiral here, actually a barred spiral back there, elliptical, likely a spiral, likely another spiral. There's lots of galaxies kind of hiding out in the background of the image. And here again, that's the companion galaxy. Galaxies aren't always by themselves. They use their gravity to pull in other objects nearby and form little groups of galaxies. But again, you can see in the background, there's actually, you can see through the main galaxy here to see some galaxies in the background, in the distance. Here and there. Another one over there. So yeah, very, very cool. Lots of galaxies in one photo. That's why we always try to start off with astronomy picture of the day. There's usually something very fun to talk about. And it gets us going. So let's actually start talking about the news. I found this article, thought it was interesting. This is from a couple days ago. 2 newly discovered pairs of quasars existed 10 billion years ago and resided in cores of merging galaxies. Number one, that looks like a critter out of Metroid. Always kind of cool. This is an artist conception. What you see here, obviously, is 2 galaxies seemingly in collision. Very, very cool looking artist conception. But the main focal point are these 2 things in the middle, one there and one there. Now, I used a word there that you maybe have not heard before. It's not the word double, it's the word quasar. Quasar, it's actually kind of an abbreviation of something. What it really means is it's a quasi-stellar, if I could speak, it'd be really nice. It's a quasi-stellar object, QSO, or some people just call it a quasar. It's an extremely active galactic nucleus. The black hole, like I mentioned about the last galaxy, well, these are going to be 2 of them, because there's 2 different spots there. They're black holes that are actively feeding on gases and dust and stars that are nearby. They actually pull them in and consume them. Where that material goes, none of us truly know, because we don't really know how black holes work. We know that they are areas that are very dense and spherical in shape, and they pull in light around them, and as light gets pulled in, you eventually get to a spot that's called the event horizon. There's that is the literal point of no return. Once you hit the event horizon and pass it, you are entering into the black hole, and you cannot come out. Even at the speed of light, you cannot come back out of the black hole. This is a literal zone where you have divided by 0. The math is goofy. We're not really sure what goes on inside of a black hole. We can see what's around it. Of course, there's lots of hypotheses and theories about them. Supposedly, you can have a black hole and a white hole. Treat it like a wormhole. Be able to travel one area to another. Not really sure if that's a thing, because we can't really test it. We can all run simulations, but we can't actually go and visit a black hole anytime soon, at least not with current technology. Usually around these things, there's what's called an accretion disk. It's a flattened out plane, a disk of gases, dusts, and materials, usually plasmas, from nearby stars that have been pulled into the black hole, and they create, again, what's called an accretion disk. Let me see if I can find an artist's rendition of what an accretion disk looks like around a black hole. Can I get a thing? Here. This is another one of these artist renditions. Ah, that's not where that goes. Hey, how are you doing? That is a terrible photo. Not very big. There we go. Let's zoom in. But yeah, this is kind of an artist rendition of what we think's going on around a black hole, especially these quasars. You actually have a material, just superheated gases and plasmas being pulled in. Because these objects are spinning, if you can, look at if you have a right hand, look at your right hand, and point your index finger forward, point your middle finger towards your left, and then your thumb straight up. Curl your index finger and your middle finger inwards, and your thumb is pointing straight up, right? That's kind of what's going on here. When you have material going in one direction, spinning around, and in the two vectors are your index finger and your middle finger. The thumb is the direction of this extra momentum here coming out of it. So this one actually is spinning the opposite way, so everything's spinning from left to right like this. And so you get a jet shooting this direction, and there's actually a jet shooting the other direction, but it's traveling so fast, it's at the speed of light, we can't actually see it because it's going too fast. Let's zoom in a little closer. Again, these are artist renditions because we've, not really been able to get too many photos of actual black holes. There we go. That's, again, an artist rendition. This is what they call the accretion disk. Accretion disk. You see the two jets, and you really wouldn't see this other one unless you're directly on the edge, the parallel side of this. Again, speed of light is the material coming out of this north and south pole of this object, and there is the black hole sitting in the middle, consuming everything around it. Again, artist rendition of what's likely happening with this picture. This is the actual picture of two quasars, quasi-stellar radio objects, active galactic nuclei, pulling in material around them. Really, really cool. The names, there's catalog names, so J0841 plus 4825. That does not sound all that fun, but it is a catalog name. Again, you can find this over on Sci News. I'm not affiliated, I should say, with any of these news outlets. I just wanted to find some interesting things to talk about instead of just sitting here talking about the sky tonight. Which I talked about on Wednesday, which I talked about on Monday, and it really hasn't changed all that much this week. I always like to kind of throw a curveball, and on Fridays talk about different things. We look at the news. This is something that I found very interesting. This one came out on Thursday. Actually, I saw it, I think, on Wednesday night, but it's this titled Thursday here. Chandra discovers X-rays from Uranus. Now, Chandra, besides being a fun name for a friend, is named for Chandrasekhar. There is an observatory in space named the Chandrasekhar X-ray Observatory. Now, if you don't know what I'm talking about when I talk about X-rays, you should probably learn a little bit about the electromagnetic spectrum. So let's take a look at that real fast. If I can find a picture big enough to... you know what? Sure, we'll use this one. Give me one moment to move it over to the other screen. Let's take a look at the EM spectrum. Perfect. It's nice and big. So, light comes in many different lengths. Wavelengths, we call them. And going from left to right, you're going from longest wavelengths, lowest energy, to shortest energy. Shortest wavelengths, highest energy. I can really speak English, I swear. So the longest wavelengths of light are radio waves. They've got wavelengths the size of buildings, give or take. So when you listen to the radio, you're tuning into very long frequencies. When you warm something up in the microwave, microwaves are a form of electromagnetic energy. That is slightly longer wavelengths, so more energetic than radio waves. Below what our eyes can see is what's called infrared, and that's what you see when you look at like FLIR heat cameras. When you see people, taking pictures of cars or objects that are glowing, they show off where things are the hottest. You're looking at infrared light. Visible light is what we can see, and that, of course, is broken up into the rainbow, the red, orange, yellow, green, blue, indigo, and violet. You see that right down here. That's the spectrum that we can see. We can't really see too much below and too much above what our eyes are built for and evolved for. Above what our eyes can see is what's, we call that visible light. Above that is what's called ultraviolet light. So Roy G. Biv, the last color is violet, so this is ultraviolet, meaning it's higher than violet. Violet, you're turning violet. Violet. Above ultraviolet is X-ray. You deal with X-rays if you break a bone, or if you need to have something kind of observed inside your body, you're probably going to get an X-ray. Or you can do an ultrasound, which is usually going to be a radio wave, so you can see two very different amounts of energy they pump into you at the hospital. Above that, we have a gamma ray. Now, gamma ray are very, very, very short wavelengths, super high energy. They are very deadly to humans. They will destroy your actual DNA if you get hit by gamma rays. To some extent, X-rays could do that as well. And you find gamma rays and X-rays around active galactic nuclei. You find them in supernova remnants. Anywhere there's a lot of energy. But you also find some of these kind of scattering from planets, especially if they have a very active magnetic field. And that's what's interesting about the photo that we started with, which was this one. That explains what an X-ray is. The observatory is named for... I guess I'll show him. I am not going to butcher his name. Wikipedia is going to be the easiest thing to find, so I'm just going to use that. Even though Wikipedia is not always the most reliable source. This is the name. Chandrasekhar is the last name, so they shortened it to Chandra. Subramanian. Not going to butcher that name again. He was an astrophysicist. Discovered many, many things. There's also a thing called the Chandrasekhar limit. Has to do with his name, go figure. Nonetheless, there is an observatory named after him in space, looking at X-rays, and it happened to take some pictures of Uranus. Now, here's what's interesting, is that if you really pay attention, if you read this, astronomers recently took a new look at observations of Uranus made by the Chandrasekhar X-ray Observatory in 2002 and then in 2017. Now, here's my problem with this. Uranus and Neptune are the outermost planets of our solar system. They are a little hard to get to, let's be honest. But it seems that even if we have an observatory up there taking pictures of things, we're just not even bothering to process the data from Uranus and Neptune. We seem to primarily focus on Mars, Jupiter, and Saturn. They are, of course, easier to see at night, and they seem to capture our imagination. We have many orbiters that have visited Jupiter and a couple that have visited Saturn. Uranus has only been visited by Voyager 2. I believe Neptune was also visited by Voyager 2. If not Voyager 1, one or the other. Yes, good. But you know, this is data that exists. We should probably be processing it. I kind of wish we had an observatory around every planet, not just one around the Earth, taking pictures of things at you know, when people get their time and want to do their observing. I mean, we should have an orbiter around Mercury if it could survive, and Venus if it could survive. We have multiple orbiters around Mars. We had an orbiter around, a couple of orbiters around Jupiter. Now I believe we just have Juno. Then Saturn, we used to have the Cassini space probe orbiting around that. That was deorbited not too long ago. Uranus, question mark. Neptune, question mark. Pluto, we had one flyby of Pluto a few years ago, and that took, you know, 20 years to get there. It didn't even enter orbit, just kind of flew by and said, "Hi, Pluto, bye, Pluto." We don't really observe the outer portions of our own solar system. We're kind of lacking on that. Probably a funding thing. You want to focus your science on the important things, you know, getting to Mars and creating moon bases and Mars bases, hopefully. But I think it'd be kind of cool if we, you know, reallocated a bunch of stuff and stopped blowing up other nations and maybe started spending money on space exploration or even more ocean exploration, one or the other. But that's just me. In any case, you've got an X-ray emission from Uranus, which is very, very strange. It looks like it's actually a composited photo. It's got X-rays, which I believe is the purple area in the highlights here. And then you've got the optical image, which is from the Keck Observatory here on the planet Earth. And they overlaid them together. And so you've got the rings of Uranus. There are rings around Jupiter, Saturn, Uranus, and Neptune. But Jupiter's rings are made of dust and don't reflect back a lot of sunlight. Saturn's rings have a lot of ice. They reflect a huge amount of sunlight, and that's why you see them very well. Uranus's rings are icy, but they're very old. That's what we believe, and so they're just not reflecting back a lot of sunlight. They do orbit around the equator of the planet, so if you don't know, Uranus is on its side. We don't know why, compared to the other planets. All the other planets have north kind of up top and south kind of at the bottom. Maybe they're tilted a little bit, but they all pretty much have that north-south axis. For whatever reason, Uranus kicked over on its side. North is over here, south is over there, so it orbits around the sun on its belly. So half the year. Oh, we got a phone call. All right, my sincere apologies for that, but you never leave your spouse's phone call unanswered. That is how you get in trouble. Plus, wanted to make sure she was okay, so. Anyway, that's what we're talking about with Uranus. Just, again, interesting that there's X-rays coming from this. It could just be that material from the sun, you know, energy from the sun and particles from the sun are hitting the upper atmosphere and exciting the upper atmosphere of the planet. Or it's something going on with the rings. No one's actually really sure. That's actually something they say here. It could be a magnetic field. It could be a complex aurora. Or it could be something to do with the rings themselves. Very, very interesting. Get rid of that. I might keep this here just in case. Next one. This thing. I have actually not seen this, but I know this existed, so I wanted to look at it. They are, again, testing the Mars Ingenuity helicopter. They've been testing it. Kind of looks like a GIF file kind of looped on itself. They actually had this little thing turn on its rotor blades and start testing to make sure that they actually do spin. That low resolution image is terrible. And here you can actually see dust on the solar panels up top, so that's never a good thing when you have a solar-powered craft. But there you can see those are carbon fiber blades. This is a small little helicopter. This is a drone that is on the surface of the planet Mars. Honestly, not sure if it's going to fly. At least hypothetically it should fly. There are no real science instruments on board other than telemetry stuff, as far as I remember. I don't think there's any like major camera systems or anything on board. This whole thing was literally just going to be a test flight to make sure that they can actually do this, because we've never flown another craft. We've never flown a craft. Let's try that again. We have never flown a craft on another planet. So if you yourself have a drone or have a friend that has a drone, you've maybe flown a drone around. It's not overly difficult. It can be, depending on how fast your drone can actually go. Like those racing drones are really a handful sometimes. But this is just a standard, you know, think of it like a little helicopter drone. And the only difference is that it's on Mars, and it takes time to send signals from here to the planet Mars. It does take, 15-20 minutes, depending on how far away Mars happens to be, to get signals there. So what they do is they kind of preload an entire sequence to the rover itself as a command station. They send information to it and say, hey, here's what we want you to do. I want you to turn the thing on, have it fly this way, have it fly that way, and then return back to where it started. And so that's the hope, is that this thing's going to be able to lift off and fly around on the planet Mars. Now, what are some of the difficulties of doing this? Well, of course, again, the distance is a thing. It's kind of hard to control something when you're literally just pre-programming it and hoping that it flies. The other thing is that Mars's atmosphere is very thin, much thinner than the Earth's. Earth's atmosphere is nitrogen and oxygen based. Mars' atmosphere is mostly carbon dioxide based. Now, it's also much thinner, which means it may not fly the same way you would think here on the Earth. Things will sound kind of differently on Mars because of speed of sound. Obviously, going through less material, going through less atoms in the air, and so things are going to sound differently and things are going to fly differently. So hopefully this little rover will lift off in the next week or two. If they are happy with its pre-flight checks, they will finally set up a flight day for this little helicopter. Not sure when that's going to be, but they have been doing all these tests. I do know that they had a selfie come back from the Mars rover, so they had the rover take a picture of itself from its arm, There is an arm under the belly of the rover that it can stick out. It has a huge science package that you see right there. Different instruments to dig into rocks and shoot lasers and things like that. But there's also some high-resolution cameras. And it took a selfie of itself, as you can see here. And eventually, I believe they had it stick its arm out and take a picture of the rover main mast, what you would call the head of the rover, it looks like. And the helicopter. There we go. There we go. Look at that. It looked back and took a selfie of itself. You beautiful, beautiful little robot. There you see again, Jezero crater throughout the background. This is where this rover has landed. Different colors on the surface. You have the reddish, oxidized, ironish rocks, and you also got that hematite looking gray along the surface. Hematite is an iron-based mineral that forms where there used to be a lot of water. Found it all over where Opportunity landed, the Opportunity rover. I call them blueberries. They're just little tiny spherical silver blobs in most of the images. Came back from that rover years and years ago. But yeah. Again, more selfies of the rover. Now, what's interesting here, I don't know why this go away. You can see, I can't zoom in because this is a video, but you see these are color coordination things. So we know what these colors are. We have them all programmed in here on the Earth. And you have them labeled here, and you have them kind of on this little circle here. This is a sundial to help kind of tell what time it is, and see if there's any clouds, because there are clouds on Mars. So if it gets dimmer, then you know there's clouds. But the color coordination, the color card there, it helps with the camera. It helps try to make true colors happen, so they can actually program in what's red, what's true yellow, what's true red, what's blue, and what's green, to help give color tints to any of the photos that come back to make it look more realistic to our eyes. That's just a cool photo. That right there is a high gain antenna to transmit data from the surface to likely the Mars Global Surveyor or any of the other orbiters that happen to be nearby to relay that data back to Earth. This tech is really cool. If you've never looked into Mars rovers, this is actually a nuclear-powered rover. Nuclear. There's a small little nuclear power plant on board. So you don't have to see any solar panels, so you don't have to worry about solar panels getting covered up with dust. And that was the problem. Well, it's not necessarily a problem, but it was one of the design flaws of the original Mars rovers. Perseverance. Perseverance is nuclear powered. Spirit and Opportunity and Pathfinder before that, they were all solar powered. And so eventually, as they drive around, they kick up dirt, soil, regolith. It's not soil, it's regolith from the planet itself. And of course, there's lots of dust storms on Mars, and all of that can cover up the solar panels, which eventually reduces the amount of solar power available to the rover, and eventually it will cause system failure. There's just not enough power to go around to keep the rover moving. So the obvious answer is to go nuclear. Let's see what else we got. Another one from Sci News that I saw earlier. Spitzer discovers 3 most rapidly rotating brown dwarfs. Now, Spitzer is an observatory. It's a space telescope. Kind of like the Hubble, it's actually out in space. You don't have to worry about the Earth's atmosphere causing any aberrations or any distortions in any pictures, because you're in space, you're taking true pictures of the object the way they are. Now, these objects are, this is not an actual photo, this is a artist rendition of what a brown dwarf would be. Now, what is a brown dwarf? Well, you have to imagine something Jupiter-sized or more massive, but smaller than a red dwarf star. It is not a star, but it's also not necessarily a planet. Some people call them hot Jupiters. But it's either a really, really big planet that is floating out in space by itself, or it's a super small star that never actually got enough material to ignite itself. It's kind of a good look. Looks like this is some of the data that came back, and that's what they assume this brown dwarf looks like. Looks a lot like Jupiter in a way. So there we go. It's 43 times more massive than Jupiter and rotates 10 times faster. That's interesting. Really cool to see how the data gets processed. You can see the brighter and dimmer areas, which implies there's, you know, some sort of changes in its atmosphere, cloud structures and things like that. Ah, yes. It is actually squished slightly. Oblate spheroids. They're not perfectly spherical, they are squished ever so slightly. You see it with the sun a little bit. You see it with the planets. As it said there, Jupiter and Saturn show that. Neptune and Uranus not as much, but you do see a little bit of it, because they're not solid objects, they are mostly gas. But again, this is what you would call a hot Jupiter, or in this case a brown dwarf. Discovering the brightness of these objects is always kind of helpful. It shows you which sides are brighter, which sides are dimmer. If it's a solid object like a planet, like a rocky planet, it means you're looking at, you know, certain mountain ranges or maybe depressions on the surface. In the case of this brown dwarf, again, you're seeing cloud structures and brighter and dimmer areas of the upper atmosphere. Very cool. So there's lots of really cool objects that are out there. I'm gonna do something dumb. Looking at comment sections is always interesting. It's not wrong. You know, a brown dwarf may likely just be a failed star. It just may not have ignited nuclear fusion, things like that. Yeah, those were the 5 things I wanted to talk about. Just to kind of get us going, if you have any questions or anything you'd like to talk about, just post it up in chat. Chat. I need your help. All right, there we go. Wanted to kind of show you the Chandra website because I mentioned it during our little chat a little while ago. Just look up Chandra X-ray Observatory. This is the chandra.harvard.edu. They're the ones that manage this. And as you can see, there's actually what we were talking about, except what annoys me is they have gone ahead and tilted the planet. They've tilted the image to make it fit, I guess, instead of putting it the way it is with the, you know, rings vertical. I don't like when they do that. Here's a look at some X-ray images of other objects. This is of, I believe, the Cat's Eye Nebula. Right over here. Very cool. You see spiraling action. And this looks like M51, the Whirlpool Galaxy. Right over here, and you see again high energy areas in the star forming areas, star forming regions. And again, talking about black holes, that's mostly what you're looking for when you're looking at X-ray and gamma ray, high energy particles and high energy emissions. You're looking for really exotic things like black holes. And again, you can't actually see a black hole, you can only see an accretion disk and action around the black hole. But this again is the Chandrasekhar website. Feel free to visit it and click around. In particular, look through the photo album. As you can see, they have year by year from 99 all the way to 2021, which is where we are now. Or you can look at objects in particular. Like if you really like black holes, just click on the section that's called black holes, and you'll get actual pictures of the high energy stuff around black holes. Again, you don't see the black hole, but you see all the energy around it. Here's a supernova remnant over here. Around the heart of our own, this right here, Sagittarius A, that is the heart of our galaxy, the Milky Way. Sitting right in there. Again, some of these are artist renditions, like this. This is an actual image from the Chandra Observatory, up top left here. And then this is kind of the illustration, the assumption of what's going on with the star kind of floating around the edge. The accretion disk, and again, you see the black hole sitting right over here. I do apologize as I sound a little weird and, you know, maybe have voice cracking now and then. Again, allergy season is upon us, and I am just not feeling all that great. Here again is a zoomed in close-up of another galaxy. Is this a galaxy? What did I click on? Gotta keep the wife happy. But nonetheless, this is a close-up of an actual area giving off a lot of X-rays. Again, high energy particles. These are all really cool pictures. I do suggest you come and visit. This is a Chandra wide field. You see, they zoom in. Cross is the thing that they're trying to pinpoint. That's where they believe the black hole or the emission source is. And again, you can actually see the ray of material shooting out of it. We talked about that earlier. When you have a spinning rotation, you have that third axis. That's where material is going to jet out, and there you go. You see it right here, actually happening. Really, really cool. Event Horizon Telescope, a network of radio antennae, blah, 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 blah. So yeah, that's the other interesting thing, is that you can find black holes with radio telescopes too. All the fun stuff's happening in X-ray, but you can see telltale signs using radio waves. M81, another picture of a galaxy, bunch of galaxies. This is the Whirlpool galaxy right there. You can tell because the Whirlpool galaxy has a companion galaxy right here. In every picture it looks like this. It's very, very cool. Nonetheless, you see again, brighter areas. These are areas where stars are being formed and they are jettisoning a large amount of energy. Please go and see these websites for yourself. Just look up Chandra X-ray Observatory. You'll find great things. Lots of wallpapers for your phone or backgrounds for your computer, or whatever you want to put it on. And again, if you scroll down here, you can look at images by location, so solar system, or you can look at images by classification, so stars, white dwarfs, supernovae, neutron stars, black holes, our own Milky Way, other galaxies, and then quasars and other cosmological things. Also got a section for kids, so if you haven't looked at this before, please take a look. Chandra X-ray Observatory. You can also find the Spitzer Space Telescope. You can see there's the article we were talking about just a little bit ago, the spinning, very rapidly spinning brown dwarf. There we go. Good explanation right here. Exoplanets and planets. Planets that are called exoplanets are planets outside of our solar system. And of course, the planets are the planets that we have in our solar system. Then you got brown dwarfs, which are much more massive than Jupiter. Hot Jupiter, some people call them, or failed stars is another way of looking at them. They're kind of an in-between thing. They're not a full star, but they're much bigger than a gas giant planet. And then anything 80 times or higher than the Jupiter's mass, it's got enough internal pressure and temperature to cause fusion to occur, and so it ignites and becomes a true star. One hypothesis has always been is that Jupiter was supposed to actually become a small star, but it never accreted enough material to do so. So we would actually have two stars in our solar system, and that would not be too much fun, I don't think. Here again, if you go to the Spitzer Observatory's website, the Spitzer Space Telescope, they do have an image section and a video section for you to peruse at your leisure. Some of these are going to be real photos like this, with descriptions, and you can click and it'll give you a full rundown of what's in the picture and all this data, just like Astronomy Picture of the Day is set up. Then you'll have some interesting artist renditions of this, which is considered to be another star system, it looks like. One of the agency's great observers, one of Spitzer's greatest discoveries was that TRAPPIST-1 star, an ultra-cool dwarf star with 7 Earth-sized planets orbiting around it. So here are the Earth-sized planets, and you see their orbits, you see how close they are to their star. Again, if you want to read more about it, just come over here and click on it. I got some really cool kind of tri-colored pictures. Almost looks like 3D. You probably put 3D glasses on and have a trip yourself. Look at that. Galactic Pyrotechnics! That sounds like a cool band name. Here again you see a spiral galaxy. You see these telltale signs of spiral arms and star-forming regions, with extra stuff kind of floating around. This is M106. This is the one we were looking at earlier, but in a different spectrum. Again, very, very interesting to see objects in multiple wavelengths of light, and again, that's why I wanted to keep this out. So if you actually combine all these different wavelengths, you can see details that our eyes cannot, because our eyes are kind of bracketed to this little area. If you can see my mouse moving around, our eyes only see this much. But all the objects in the universe, they give off all these different wavelengths, especially stars. They give off all these different wavelengths. Here on the Earth, only certain ones actually get through the atmosphere, so that's what the Y and the N are up here. So N, ultraviolet doesn't get through our atmosphere, X-rays and gamma rays, they don't get through our atmosphere. And so you can't put an observatory here on the Earth, you have to put them in space to be able to see those. Visible light, yes, it gets through. Infrared, a little bit it gets through. Microwaves, nope, that does not get through our atmosphere, it doesn't get through our magnetic field around our planet. And radio waves, they do get through the atmosphere, and so you can have radio observatories like Arecibo, like the Very Large Array, here on the Earth. But to see these other objects, especially up here, the higher energy objects, you gotta get space observatories. That's why you got the Spitzer, that's why you've got Chandrasekhar. Hubble sees visible light and ultraviolet light. Please appreciate the Hubble. If you've never gone to their website, it's just hubblesite.org. Hubble's been up there for a very long time. It's becoming kind of an old and haggard instrument. Of course, Hubble was captured and repaired a few times when we had space shuttles. That is no longer a thing. We cannot capture the Hubble Space Telescope anymore because we do not have space shuttles to do that. And so, if something ever goes wrong with the Hubble, they're just going to have to deorbit the thing. Like, it's just not going to exist anymore, and that's really, really sad. But if you go to their website, again, you can get really, really cool pictures. You just see down here where it says down. Let me make it bigger because I have a 4K screen. My apologies. You see on the bottom left here, it says download options. You'll notice this one that says full res, that's 103 megabytes. That is a huge photo. So do pay attention to which ones you click on. I have a very fast internet connection and you still see it takes a little while to load on in. This is the region around Orion. Which, again, we've talked about throughout the whole week on where to find it and how to find it, but you see Orion's belt, the 3 stars right down the middle, Rigel, knee star down here, Scythe, the other knee star, Bellatrix over here, and Betelgeuse, the red giant star in the shoulder of Orion. Huge amount of interstellar gas and dust, bright red, showing off the hydrogen alpha regions, areas that are very active and heated up. And of course, the Orion Nebula right in here, where stars are actually being born, or forming, I should say. I actually don't know what these little yellow dots they've added in are. I'm sure it explains it somewhere. This ground-based image offers a wide view of the entire Orion cloud complex. The red material is hydrogen gas, that's what I mentioned. Let's see if they... Undulating line of yellow dots beginning lower left. Superimposed image of 304 nascent stars taken by the Hubble Space Telescope. So these are actually other little stars that are kind of formed and trailing around from this area. So that's really, really cool. But again, if you've never looked at these are free to go visit, and you can download them. And as far as it's not for commercial purposes, I believe as a citizen of the United States, you're able to just use this for whatever you want. So download them, take them to your local print shop, print them up, put them on your wall, find a cool photo, put it up in your house, be that nerd, celebrate being a nerd. Let's take a look at this. Yeah. Huh, weird, it didn't have a bigger picture. Lame. Lame! There we go. There it is, down here. Ooh, pretty. Look at that. Again, you can see the distinct difference in colors of stars. Brighter blue stars, or at least more prevalent looking blue stars. Those are going to be the hotter stars that don't live as long. They are literally burning through their cores faster than the other stars in this image. Most of the time when you look at pictures like this, you're going to see, especially if it's an older grouping of stars, you're going to see red and orange colored stars taking up the majority of the image. This is the wrong telescope. Go back. Oh god, what did I do? There we go. Anyway, again, our Friday shows is just us kind of sitting around talking about whatever, doing whatever. Someone asked me about, different websites, and there we go. That's something I've talked about during the week whenever we talk about the planets. You see there's a copyright on it, so you can see how you can use that, but this is a picture of Neptune, which actually isn't all that great of a photo, but it does show something interesting. With Neptune, there is a dark spot. So with Jupiter, we have what's called the Great Red Spot, a reddish-colored cloud in the upper atmosphere. But with Neptune, it's actually what's called the Great Dark Spot. We're not really sure how it gets there, because, well, it shouldn't exist, to be totally honest. There's not enough energy going to the planet to make clouds like this happen, but yet here it is, and that's an actual picture of it. Now, while I would love to stream a little bit more, unfortunately everybody seems to keep calling and needing me, so everybody's forgotten that today's a streaming day. So it looks like I might have to actually cut this a little short. I did answer a couple of questions that were sent to our Facebook page. Now, throughout this whole entire thing, for future reference, we are on YouTube and Facebook and Twitch all at the same time. I can see all the chats all at the same time. Sometimes I can reply directly to you. Depends on which interface I'm using. So I really do try to answer them. If I'm not answering them vocally, I will answer them in a message to you. So please make sure you like and subscribe to each of those channels so that you don't miss out. Use your favorite outlet if you like Twitch. If you're a gamer and you're always watching people playing games, reason I actually get to do it on Twitch, or that I do use Twitch in the first place, is that a lot of the times I actually use Universe Sandbox, which is a game on Steam that you can purchase. This is what it looks like. It allows you to kind of fly in and fly around various simulations that people have made, or you can make simulations yourself. There we go. Plus, that lets you kind of load in different size stars and things like that, and really delve into, how gravity works and how things collide. Things like that. This is actually a simulation that I used in our planetarium shows. This is the Milky Way on the bottom and the Andromeda Galaxy up top, and they will be merging together as galaxies tend to do. So yes, this is Universe Sandbox. Feel free to grab it from Steam if you'd like. Again, I'm not affiliated with them. I just like using it because it lets me, do what we're doing right now. Lets me teach. The other thing is Stellarium. And that is, of course, the planetarium software that I use on an almost daily basis. There we go. Again, I am not affiliated with them either, but they do have it for Linux. They have it for Windows and for Macintosh as well. So whichever operating system you have, if you have Ubuntu, you're looking for the Linux installer. If you have any sort of Mac OS, Sierra, High Sierra, Catalina, what's the new one, Big Sur? You're looking for the Mac installer right there, that .dmg file right there. If you're looking for the Windows installer, they have the Windows logo on them. get your .exe on or .msi on. And install this so you have your own planetarium for your own usage at home. Again, it's free to use. Lots of really cool stuff inside of it. Looks kind of like this. Lots of different sky stories and sky lore available. Again, I am not affiliated with it. I just like to use it. Star lore. Unfortunately, some of the Star lore ones only give you stick figures. They don't give you actual pictures because some of these are incomplete. But these are some of the tools of the trade that, at least that I'm using. They kind of help make this a little easier for everybody to understand and to use it as for teaching tools, I guess. Speaking words, obviously. Nonetheless, it looks like I am being summoned, so I'm going to have to cut stream short today. That's unfortunate, but it is what it is. I hope you and yours are safe and well. Please continue to be good human beings. Take care of yourself, take care of each other. Astronomy is for everybody. Please go outside and look at the sky. Check the YouTube archives for previous live streams, in particular the previous planetarium streams, so you can learn a little bit about what's going on in the sky if you haven't been keeping track. Please do so. It was wonderful to see some familiar names in chat. I always appreciate you guys showing up. It really warms my heart. It really does. Please take care. We'll see you next time. And by next time, I mean on Monday. And of course, we're going to live stream whenever they do the Mars Ingenuity helicopter. Whenever that happens, we are going to go live and watch that as well. Have a great weekend, everybody. Take care of yourselves.